Alright, last page, and we're going to talk about continuity. And basically, the definition of continuity is the same as the definition for continuity in one independent variable. So recall that evaluating limits of continuous functions of a single variable is easy. I'm just going to go ahead and I'm not going to read this out loud. Just know that I'm just going to talk about the definition. So a function of two variables is called continuous at a, b if the limit as x and y approach a and b of f of x, y is the same thing as the function defined at a and b. If you evaluate the function at a and b and you get, the limit, then it's continuous. We say f is continuous on D, and if f is continuous at every point a, b, and d. Alright, sums, differences, products, and quotients of continuous functions are continuous on their domains. If f is a continuous function of two variables and g is a continuous function of a single variable that is defined on the range of f, then the composite function. So we're going to talk about composite functions now. H is equal to g of f, defined by h of xy is equal to g of f of xy, is also a continuous function. So all we're going to do is find h of xy, which is just going to be g of f, and then the set of which h is continuous. So here we have g of t is equal to t plus natural log of t, and then f of xy. So h of xy is equal to g of f of xy. So basically, we're going to substitute an f wherever there's a t in g. So instead of saying t plus, we're going to say 1 minus xy over 1 plus x squared y squared plus the natural log of 1 minus xy over 1 plus x squared y squared. That's it. That is the composite function h of xy. Now, again, we want to define, where h is continuous. And so where h is continuous is going to be defined by x, y, when x and y, and when we have 1 minus xy over 1 plus x squared y squared is greater than 0. And the reason for that is because, that entire function right there is inside of a natural log, so it has to be greater than 0. Another thing that we notice is that we have, a denominator. Notice underneath the denominator, not allowed to have 0. But for this case, 1 plus x squared y squared, you're never going to be 0. All right? And because you're never going to be 0 in this case, you don't have to say 1 plus x squared y squared cannot equal 0. Because it's not going to equal 0. So, where is h continuous? H is continuous as long as 1 minus xy divided by 1 plus x squared y squared is greater than 0. All right? And that's it. Now, the last part, functions of 3 or more variables, if we're trying to find the limit, we're going to approach it the same way. If we have 3 independent variables, the first thing we're going to substitute in and see if we get a value. If we get 0 over 0, then we want to try a few different pathways. All right? And then more than likely in this class, once you try those few different pathways, you're going to realize, oh, hey, it does not exist. All right? You're not going to do the squeeze theorem.